Hi, this is part one of a two-part video about using Kinect to browse through information sets. The information here is a simple set of example nodes and collections held in a triple store. It will allow me to browse through libraries of images or points of interest, and its original implementation was to browse through the metadata associated with video libraries to find video clips. Let me give you a quick demonstration of how it works. This is one of the presentation controls called a radial. With a mouse I can squeeze or rotate the items on view. I can expand a point and spin the mouse wheel to fan the expanded items. And when I find something of interest, I can drag the mouse down to get a full list of available actions. Here I'll select to play this video clip. I can pause or play the video or scratch through it. If I decide I'm going to use this clip in a project, I add it to my scratch pad and then go looking for something else. I originally developed this software for IPV in Cambridge and its name was Terragator. I've changed it to Dragonfly here to avoid any confusion. I can achieve a lot using the mouse, and we've all developed some motor skills to allow fine movement control and the ability to double click. But this experiment is to see if I can get anything more, or even if it's possible to use the Kinect instead of using a mouse. Okay, so let's take a look at what I've got here. I have a mashup of, on the right, the Dragonfly browser. This has been ported from Silverlight to WPF. And on the left, the Kinect WPF viewers from the Beta 2 example source code. I also have the speech recognition from the Beta 1 example source code, and I've added in a rudimentary hand gesture recognition system which is based on histograms. The hardware I'm running is the Kinect, plugged into its power supply, which is plugged into a USB port on my computer. I'm using Beta 2 of the Kinect library from Microsoft, along with Visual Studio 10 and version 4 of the .NET framework. I'm not using any open source Kinect drivers or libraries, nor any image recognition software such as OpenCV. If you're familiar with the skeletal viewer from Beta 1 of the Kinect library, or the Kinect WPF viewers from Beta 2, then you'll recognize the color image, the depth image, and the skeletal image here on the left. I've added a hand tracking image beneath the depth image, which looks for the nearest point in the depth image, then iterates around that point to find a hand. I then apply some averaging to give a smooth bounding rectangle over the nearest hand, and draw a red circle over the nearest point. Finally, I build a set of histograms from the image data and use those histograms to identify gestures. At the bottom left of the window, the last hand gesture or voice command is recorded. I also have an image at the bottom to tell me if the software is acting on voice commands. The voice commands are turned on and off with mic on and mic off. Mic on, left, right, up, down. The hand gestures I have are open hand, fist, L, hand right, hand up, and thumb up. I also have the red spot which I could use as a cursor. This is the nearest point averaged over 1 second. The two main cursors I have on the browser window, one for each hand, are color coded with black meaning furthest away or inactive, and then red, orange, yellow, and white, depending on how far out I straighten my arms. To link the Kinect to the browser and make sure it's all working, I have a few voice commands which I shall demonstrate. Clear, new radial, clear, new carousel. With the image carousel, I shall now pin the mouse cursor to my right hand cursor. Cursor on. As you can see, it's still fairly rudimentary, but the task for part 1 was to get Kinect talking to the Dragonfly browser, which has gone quite well. Now I have a platform to see just how capable the Kinect might be for navigating through data sets, or at least enhancing the way we currently navigate using a keyboard and a mouse or touch screen. To summarize, we have motion tracking in 3 dimensions, we have voice recognition and some static hand gestures. The next step is to try and understand dynamic gestures and how multiple inputs from hands, arms and head in motion can combine with hand gestures along with voice commands to allow navigation through complex data sets. Thanks for watching.